When you ask the AI to write code without understanding the architecture, it starts from scratch every single time. This is lesson 4 of the course on launching SaaS applications. Last video we set up the environment and got OneShot running locally. The app opens in the browser. Links to our lessons in the description. Today, architecture. How the code is organized internally, how that affects the quality of what the AI writes, and at the end, we'll add an API keys module. From task to working result in the browser. My name is Eugene. I've been in development for over 20 years. Everything I've built is on GitHub for free, so you don't start from scratch. Link in the description. Here's our plan for today. We'll cover how code is organized in a web application, how a request comes in, who does what, how the parts talk to each other, then how that looks when the app is already large, with a dozen different features and modules. Next, where to keep logic that's needed in multiple places at once, and how to connect external services in a way that makes them easy to swap later. After the theory, practice. We build a real module in OneShot. Question while we get started. Drop a number in the comments. If the AI has already written you code that you had to redo later, type 1. If you haven't gotten there yet, type 2. If everything's been fine so far, type 3. Let's start with the basics. When a user opens a page in the browser, the application receives a request and has to return a response. How is that path organized? This is MVC. MVC stands for Model View Controller. 3 roles with separate responsibilities. Let me show this with a concrete example. Say a user opens a page showing their payment history. It starts with the router. Think of it as a lookup table, mapping URLs to code. A request comes in for billing history. The router checks the list and says, this address is handled by the billing history controller index method. The controller takes over. The controller is the conductor. It doesn't store data and it doesn't draw pages. It decides what needs to happen. Load payments, load subscription info, check if the trial period has expired. For each of these, it calls the corresponding model. The model is the data layer. The payment model knows how to pull payments from the database. The subscription model knows the subscription structure. The controller asks, the models answer. Once the controller has all the data, it passes it to the view. The view is the page template. It receives an array of data and turns it into HTML. Payment table, subscription status, buttons. That's the full cycle. Request, router, controller, models, view, response. Why this separation? Not for architectural beauty. When roles are separated, you change a template without touching the database. You change a database query without touching the page, and when you assign a task focused on a specific controller or model, the AI works on that isolated file without breaking everything else. That's the direct practical benefit. In OneShot, every module looks like this: a controllers folder, a models folder, a routes file, and a views folder. Everything by role, everything in its place. Now imagine you have a full SaaS, not just one page. Registration, personal dashboard, billing, API, admin panel. If you dump all of that into one controllers folder and one models folder, after 2 months of development, nobody will know where anything is. That's why HMVC was invented. Hierarchical MVC. The idea is simple. The app is split into modules, and each module contains its own MVC inside. In OneShot, every module is a separate folder. The auth module handles registration and login. The users module handles user management. The billing module handles subscriptions and payments. Each module is independent, its own controllers, models, routes, and views. When you assign a task and point to a specific module, the AI reads that module's documentation, understands what's in it, and writes code that fits into the existing structure without touching anything else. That's the main advantage of modular architecture for vibe coding. Now, inside each module, there's another layer of separation: contexts. In OneShot, there are 4. Front is the public site, landing page, public blog. Anyone can access this without logging in. This is where you tell visitors about your product. App is the authenticated user's dashboard. Profile settings, operation history, everything your user interacts with after logging in. Admin is the admin panel, list of all users, content management, analytics, everything an administrator does to manage the project. API is the REST API, returns JSON, no HTML pages, used by mobile apps, third-party services, and integrations. One module can operate in multiple contexts. The users module lives in admin, where the administrator sees all users, and in app, where the user edits their own profile. Different controllers, different views, but the same user models. This combination, modules plus contexts, gives clear structure to any SaaS application. Open a folder and you immediately know where everything is. Let's cover 2 more things that don't usually get talked about. They're the ones that solve problems when the application starts to grow. Subscribe. The next lesson on API integrations builds directly on the architecture we just covered. Leave a like up front. If the video turns out useless, you can take it back at the end. Here's a real situation that happens in every SaaS project. You build user registration, write a front controller, handle the sign-up form on the website. Then you add an admin panel, and there you also need to create users manually. Then you add an API so partners, your mobile app, or integrations can create users in your system. 3 contexts. In each one, you need to do the same thing. Hash the password, write the user to the database, send a welcome email, create the initial account settings. If you write this logic in each controller separately, you get 3 identical chunks of code. When you need to add a 4th step, say log an event, you have to edit it in 3 places. Skip one context once, and behavior differs. Bugs like that are the worst kind. Everything seems to work, but not consistently everywhere. You could move the logic into a model, write a method in user model, call it from all 3 controllers. Better. But a model has its own responsibility, working with data for a specific entity, users in this case. When the user model starts containing email sending logic, account setup, balance handling, it bloats and loses focus. Over time, everything gets thrown in there. Services solve this problem. A service is a class containing business logic that doesn't belong to a specific model. For example, a user registration service. It takes form data, calls the needed models, runs all steps, and returns the result. 3 controllers call one service. Change the logic in one place. It works everywhere. In one shot, the rule is simple. Create a service when one piece of logic is needed across multiple contexts, or when an action touches multiple models at once. If a controller works with just one model, no service needed. The moment a second controller needs the same logic, extract it into a service. A service is exactly the concept I mentioned at the start. Its absence isn't visible right away. You notice it later, when bugs start appearing in unexpected places. Last key piece, providers. This is about connecting external services. Imagine you wired up email sending through Mailgun. 6 months later, you decide to switch to a cheaper provider. If your code calls Mailgun directly all over the place, you have to find all those spots and rewrite them. In a large application, that's a real problem. A provider is a layer of abstraction. All the application code says is, send an email, without knowing who sends it. In one place, it's written, emails go through Mailgun. Want to switch? Change that one place. Nothing else is touched. In one shot, that's a folder in the project root with ready-made connections. Stripe for payments, Mailgun for mail, Telegram for notifications, Google Cloud Storage for files. Want to add a new service? Just tell the AI. It looks at what's already there and builds the new one the same way. How exactly to call providers and connect external APIs is the topic of the next video on integrations. Link to all lessons in the description. Theory covered, MVC, modules with 4 contexts, services, providers. Right now, these are just words. You need to see how all of it works together on a live project. Let's build a module. A real one, not a tutorial exercise. API key system for one shot. Users create keys to access their application's API. This will use everything we just covered. A module in 2 contexts, app and admin. A model, a service with security logic, a filter to protect API endpoints, and one interesting detail about how to store keys securely. Here's the task we give to the AI. We need to create an API keys module. Key format, the prefix one shot, chats, followed by 32 random characters. Show the key only once. Store only the hash in the database, plus the last 4 characters. On validation, compare hashes. We specify the editable fields: key name, active status, expiration date, request limit, credit spend limit. An option to set how many days these limits apply, convenient editing interface, multiple authorization header formats supported. In the app itself, list all keys, edit them, activate, deactivate, delete. Admin sees all keys across all users. Now we test. Send a public request that doesn't require a key, should respond with current time. Send a request with a key to get key info. That endpoint does require a key. Watch the process. The AI doesn't jump straight to writing code. It reads the documentation first, sees how other modules are structured, what naming conventions are used, how routes are registered. That's why the code fits in on the first try. Once it's ready, we open the dashboard, create a key, name it test, set a request limit of, say, 10 per day. After submitting, we see the page with the key. Notice, this is the only time it's shown. This string right here, the only time it ever appears. The database stores only the hash of this string. If the database leaks, the keys are useless. You can't reverse a hash back to the original. Let's check. Send a regular request. Status OK without a key, and we see the time. Now send a request to the key info endpoint without passing a key. Access denied, not authorized. 401 error. The error message tells you exactly what happened. Now send the same request with the key in the headers. We see the key name, the limit, the request count so far, whether it's active. Ping, public, responds without a key. The key endpoint, without a key, 401. With a key, all good. Send a bunch of requests in a row. The rate limit fires, limit exceeded. Here's how it works internally. The API key filter runs before every protected endpoint. It pulls the key from the headers, searches for a match by comparing hashes. If the key is found, active, and within its limit, the request goes through. The counter increments by 1. If not, 401. Module is done. Here's where everything we covered today came together. Module in 2 contexts, app and admin. The key model handles data, the filter acts as an auth service, endpoints live in the API context, everything in its place, everything easy to find, but understand what we actually built. We built authorization, a system that checks who's knocking on your API door and either lets them through or blocks them. That's the foundation. The API itself, what it returns, what data, what logic it runs, that depends on your application. Different for every use case. How to build that is in the next lesson. Next video is entirely about API. 3 things. First, what an API is and how it works. Second, how to build your own API so other services or mobile apps can connect to your product. Third, how to use external APIs, meaning how to connect other services into your own app. The providers we covered today will be in action. If you want to build your own SaaS with this architecture without figuring everything out alone, I help with development. Link in the description. Summary on architecture: MVC, model, view, controller, HMVC, modules, each with its own MVC. 4 contexts: front, admin, app, and API. Services, when one piece of logic is needed in multiple places. Providers, integrations with external services. Last question: what module do you want to add to your product? Something unique to your idea or one of the ones we covered today? Drop it in the comments. I'll explain the best way to approach it. I reply to everyone. Links to all lessons in the description. See you next time.